Okay, in this video we are going to look at what is going on with this sensor. So this is the optical flow sensor, which is MTF02P. So based on the website, we can see that it has several protocols that are supported. It has the microlink, which is the default, that is like a custom protocol that they are using to send the data. We will worry about passing the data later, but based on this one, like based on the specification, they say that the supply voltage is 5 volt, but the UART or the voltage is like not clearly mentioned. I think, I don't know, this says LVTTL. I don't know what that means. Let's quickly search what this means. Okay, low voltage transistor logic means like it is on 3.3 or 2.5 or so. Anyway, they have given that it is like, I did not notice that earlier. So anyway, they say that this is like low voltage TTL, but I just wanted to make sure before I connect everything to this TNC microcontroller over here, because like the power supply voltage, they have mentioned that it is 5 volts. So sometimes we might get 5 volts out of the UART pin. So that's what we need to avoid. So that's why I wanted to make sure that everything is like in 3.3, because TNC only supports for 3.3 volts for its serial communication. So first, based on this diagram, based on the pinout, it says that the bottom pin is the ground, and then the 5 volts, then the receiver and the transmitter. So by default the jumper is not connected here. So near default there's no jumper. So we don't have to worry about configuring it to AutoPilot or PX4 firmwares. We just need to make sure that whatever the default protocol call Microlink works. So let's see. We just want to get data out of the TX pin. That is the pin that is going to transmit the data out of the sensor. So that's what we are going to see. So right now I have like supplied the sensor with 5 volts. That's why it's on, and this blue color LED is turned on. So starting from the bottom, in this orientation, this is the ground and this is the 5 volts. So the next pin will be the receiver pin. So we can also check the voltage of the receiver pin, which is not that necessary for this application, but anyway, let's check. So I'm connecting the positive lead of the multimeter to the receiver pin, as well as like I am going to measure it with reference to the ground. So here you can see that it is 3.2 volts. So next thing that I'm going to do is like I'm going to check the voltage of the transmitter pin. So this cannot be 5 volts, or else it will damage our microcontroller. So in this case you can see that for some reason it is coming up as 3 volts. So the green wire is going to give us a reference of around oh, it turned off. Okay, but turn back on. Maybe it's a loose connection, but I want to verify it again. So right now I'm measuring the voltage. So what's going on? Okay, okay, some loose connection. So it's around 3 volts. So it's definitely safe to use the TNC microcontroller along with this sensor, which is MT F02P. So I just said check the specifications, and it has these ranges. Dead zone is 2 centimeters, so I think it cannot measure anything uh, below that. So, and the maximum speed measurement is 7 meters per second at 1 meter height. So this is what it can actually measure. So typical range is like 60 meters at 90% reflectance, and 4 meters at 90% reflection. So something, so it's basically like having a range of around 6 meters. So but they are saying that the test data is around at 1 meter height. So anyway, so I think for uh, hovering applications for a drone, it might not be a problem. So optical flow working distance is mentioned as 8 centimeters in this case. So that's regarding this sensor. Let's see how we can get the data out of this sensor to the Arduino in the oncoming videos if it's possible. Okay, thank you.